So let's get started. Hello, everybody. Welcome to OpenCV weekly webinar. And today we have with us Team Caleta, who won the second grand prize overall, and they were the first European team. Welcome, everybody. There are 4 team members here: Daniel, Lionel, David, and Angel. And with us is also Phil Nelson, as always, who is the content manager at OpenCV. And he puts together these webinars, helps out in many different areas. Welcome, Phil. Welcome, Team Caleta.
Yeah, hey there, everybody. Welcome back to another OpenCV weekly webinar. If you're just joining us for the first time and you don't know, we will have a giveaway toward the end of the webinar here. So stay tuned and you'll have a chance to win. Satya, would you like to tell them what they'll win?
Yes, you will win 200 hours of free Azure credits. And that's because this is part of OpenCV AI Competition. Still, we are giving away the prize from our sponsors, Microsoft Azure and Intel.
Yes, thank you to our generous sponsors. We will also be doing Q&A during this session, so please use the Zoom Q&A functionality. There's a little button at the bottom of your screen there. Click that and ask your question at any time during the webinar. If it fits in during the flow of conversation, maybe we'll ask it early, but otherwise we'll try to answer as many as we can in the last 15, 20 minutes of the show.
Right. So actually, to just get started, we should go over, the team actually has 10 people in all. Unfortunately, because of the limitations of the webinar format, we thought that 10 people may be too many to go over. So the 4 people representing Team Caleta, it would be great if you could introduce yourselves, just a short introduction, maybe a line or 2 about yourselves, so that the audience knows you. That would be great.
Yeah, I just need enough time to put a lower third down there that has your name on it.
Okay, so
Go ahead, David.
okay, I'll break the ice then. So my name is David Gomez Ullate. I'm a researcher at the University of Cadiz, and I work mostly on data science and machine learning. Rather new to computer vision, but thanks to the rest of my colleagues, I was brought into this project.
All right, Angel.
Hey, welcome everybody. My name is Angel. I'm a researcher currently at the University of Granada. My expertise is software engineering, IoT, and full stack development. In the Caleta team, I was part in the development of the background of the backend and the front end of the end solution.
Awesome.
Hello, everyone. My name is Lionel Cervera. I'm a researcher at the University of Cadiz, specializing in computer vision. And well, among my roles, I work on the algorithms for the NeoCam, on the hardware part also, and some of the tests.
That's great. Lionel, before we move on, you are the one who named the team. Can you tell us the right pronunciation? Because I'm pretty certain that I did not pronounce it correctly, and the reason the name was chosen.
Okay. The name of the team is Caleta. Caleta is a very well-known beach here in Cadiz. It's a wonderful spot by the seaside in this wonderful town that should all visit. Even Halle Berry, the actress, appear in a movie, or James Bond movie, having a bath in this place.
That's the claim to fame. Great.
It's a very beautiful place. And Daniel?
Yeah, hello everyone, glad to be here. I'm Daniel Precioso. I'm a PhD student here at Cadiz University. I'm studying machine learning, so of course I was part of the development team in the software side.
That's great. Let's start with the presentation. There's a lot to go. This is an amazing, it is one of those things, I think as far as impact is concerned, the things that you have built for neonatal care using OpenCV AI Kit, it just blew our mind. It is, it's really fantastic. So I'm sure that our audience will really appreciate how far you were able to push and how close to real life. Like this thing was actually installed in neonatal care units. And this is all done, in three months. It's amazing achievement.
Okay, let me see if I can share my screen. Okay, do you see the screen?
Yeah.
Okay, well, first of all, many thanks to both Satya and Phil for inviting us over. It's really a pleasure and a big honor to be able to share our work with all this community. And as Satya said, this was really a very interesting project, and it was all motivated by the competition. So we are extremely thankful for you for putting up the whole competition and giving us the excuse to get into working on this problem. Okay, so we prepared a few slides. There's going to be three of us talking, so I'll be handing over the floor to my colleagues. But first of all, let me show you what the outline of what we want to present. This is the machine that you're seeing on that picture, and it contains an OAK camera and some other hardware that you will see, and it's being used in the intensive care units at the hospital, and we will tell you the whole story. And the main part, the three algorithms that we developed that are going to be used will be the first thing we'll be discussing. One of them measures the breathing rate without contact, and this is a big novelty. The other one measures the motor activity, whether the children are moving, how they are moving, and so on, which is also a rather new thing, because so far there are not clear ways in which you can measure this in this neonatal units. And the third one, we call it emotional status detection, which basically it's an image classifier to tell from the video whether the baby is having pain or not. Next, we'll discuss how this NeoCam unit is built, what are the whole hardware specs, and Angel will be in charge of telling you all about it. And also the system architecture, because it's not just the camera that we developed for this project, but there's a whole hardware and software system of interconnected elements and a mobile application that serves the whole suite, the whole purpose. Okay. The mobile application, we will also explain it. And finally, Lionel, who was the person actually in charge of most of the project and the one who was in the hospital, he will tell you how it was to try all this thing out at the hospital. So this is in a nutshell what we'll be talking about in the next 30 minutes or so.
Awesome.
Okay, so here's motivation. There's a lot of words here, but let me try to summarize the main ideas on what's driving us and why this thing is a novelty in the intensive care unit for babies. Well, the main thing is that most of the sensors that are now measuring vital constants on the babies are attached to the skin, and they all involve cables, and they all are rather cumbersome because, I mean, first of all, you rely on these things being well connected. Sometimes they cause certain pain or distress to the baby, and they are, let's say, let's call it old technology. Okay, they still work very well, of course, but then we thought maybe we could try to measure some of these quantities without any contact by just using a camera and some new ideas. And this is mostly what we did. Now, the other main idea is that we are able to measure some of the things that are measured by those sensors, but also other new things. Okay, like for instance, whether a baby is having a pain or not. It's very hard to measure that with a sensor, but with a camera, by reading and interpreting the baby's expression, you can do that. Yep. Likewise, it's quite hard to measure the motion of the limbs, of the arms and the legs of a baby with a sensor. But with a camera, it's quite easy to do. And the key thing here is that you have 24/7 connectivity. Normally, doctors have very limited time to look at babies because they have to see many of them. And at most, they will look at the baby for 5-10 minutes, observe. And then, yeah, I mean, if they are lucky to see what they're expecting to see in those 5-10 minutes, then okay, they can reach a diagnosis. But if you have an intelligent system that is doing a 24/7 monitoring of the baby, it's able to see many more things and inform the MDs of certain alerts or certain abnormal behavior and raise alerts when they need to be. So we feel that that this technology might actually have quite a big impact in the way things are being done now at intensive care units. Okay, and our main drive was to try to showcase this this technology. We built most of the thing from scratch for the competition. And yeah, it's still work in progress. We still need to validate many things, but I think at least we were able to show in this project that that the thing can be done, and it's very promising. So these are the highlights. As I mentioned, real-time monitoring without contact of these three quantities: breathing rate, motor activity index, and emotional status. Everything has been done using open source and commercial technologies. And there's this whole other extended ecosystem that my colleague Angel will tell you about, and all the tools that we developed that go together with this application. Now, this thing, our idea is that it could serve a double purpose. It could serve for the parents of the children. It's very hard for a parent not to be able to be with your child when it's in the intensive care unit. Sometimes they're only allowed for a certain time inside. And to be able to monitor your own baby that is just maybe a few days old through image, it's probably quite an important thing.
Yeah.
But also to medical doctors, I mean, this allows them to have a constant monitoring of all the children that they have, all the babies that they have in their intensive unit, and receive alerts whenever they need to take certain actions. So this is the two main applications that we thought for this technology.
Right.
Okay, the three algorithms that I will be describing very shortly, we managed to have them work simultaneously inside the OAK-D. Okay, so two of them use only the color camera and certain built-in face detectors and other deep learning models, computer vision models that run inside the camera. And the third one uses the three cameras, the two monochrome and the color camera, because they use the depth estimation to measure the breathing rate. And again, we were able to encode all these models inside the camera, and the output is sent to a Raspberry Pi that does a certain number of things that we'll be telling you in a minute. So
this is about as good as it gets, you know, three important models all running on the device. And because you have Raspberry Pi, you know, you don't need a very powerful computer. You could get away with Raspberry Pi because all the processing is being handled by OAK-D. So it's beautiful.
Precisely, and actually, I can tell you, Satya, that we pushed the OAK-D, I think, close to the limit, because some of the larger deep learning models were actually hard to fit, even if we passed them through the OpenVINO toolkit. So this actually places some limitation on how large a computer model could be. So right. Yeah, but as you say,
I ask quickly about? So you did use OpenVINO. What kind of savings did you see with OpenVINO?
Well, I don't know, maybe Danielle can respond to this, but I think at least half of it, of the size of the model, if I remember properly.
That's a huge benefit. I mean, it's basically free performance, you know?
Yep.
So in our consulting services, the first time I used OpenVINO, we saw a 3x improvement in real-time performance of a background removal algorithm. So that was eye-opening, because it was not part of our pipeline before, because you know, we were optimizing the model in other ways, but it was pretty surprising, especially when you want to run this thing on a CPU or a VPU. It's they've done a very good job.
No, this whole thing of edge computing, I think, is going to be a revolution in computer vision, and is going to allow not only for this project but for many others. This processing on the edge will I think is going to be a game changer, actually. But okay, now we're getting a little bit too far ahead of us. All right, so let me try to explain you without going into many of the details, but at least the ideas underlying the three algorithms and how we made them work. Well, the first one is how to measure the breathing rate, and this was a brilliant idea that Lionel had, and it is, first of all, you detect the face with a built-in face detector, and you detect the face because what you want to focus really is on a region around the chest of the baby. The chest, the thoracic region, is the one that expands and contrasts more clearly when you breathe. So relative to the head, then we just coded certain parameters, and because normally proportions are very similar across all babies, so the chest will always be more or less on the same region relative to the head. There we define this region of interest, which is a small rectangle near the chest, and within that region we use the depth estimation feature of the OD. And this gives us the depth of every pixel in the region. So what we do is we average over the whole region. This gives us a bit of a more robust estimation of where the whole skin of the chest is lying.
Right.
And then this gives us a single quantity per frame.
Right.
And this, we call it a C of T. It's just a time signal. So what we need to do essentially is, because this signal is going to be periodic, we need to find the peaks, we need to smoothen the signal, normalize it if needs be, and find the peaks. And the breathing rate is nothing but the number of peaks per minute. Okay, so very simple, but I think it's a great idea.
Did you have any problems? Do the neonatal babies, do they actually turn or they are usually on their back? That's not a problem.
That would be a problem, of course. Yes, I mean, most of the trials that we did were assuming that the baby was facing upwards.
Okay.
If the baby is turning, I mean, babies normally of that age do not turn because you place them, they still don't have the ability to turn.
Right.
They don't have the muscles developed and stuff, or even the wherewithal to try, probably.
Not yet.
We check with the neonatologists exactly. I mean, in which conditions are the babies usually, and I mean, if they are at some point turned down, is because they have to do something specifically, but in general they keep all the babies facing up.
Right. And I mean, I'm just assuming that you know, there are so many wires connected to the baby that, you know, if they were actually turning by themselves, that would be a big problem for them. But maybe the babies of this age or not, you know, they are in the neonatal care unit, so they are really tiny and also not very capable. The muscles are not developed, etc. So okay, makes sense.
Satya, you're going to see the videos right now, and the motions are very limited. I mean, basically, the only thing they do is something like this.
Right.
So you're going to see it probably in the next slide. They have a very limited range of motions.
Yeah.
Okay, so this is a video that showcases how the thing is actually working. This is one of the earlier versions of the software. So you still see the output on a laptop. On later versions of the NeoCam unit, we actually had a built-in TFT screen on the device itself, but this was one of the earlier versions. And if I play the video for you, let me see if I can make it bigger. So there you see the baby. The camera is, you don't see the camera, but it's on top. And here you see the depth field.
Yeah.
There it seems to stop for a while. Like
wow.
The baby is not breathing, and then it resumes again.
Yeah.
These things actually do happen. I mean, babies sometimes they hold their breath for quite a few seconds.
Wow.
So it's not strange actually. And this was actually told to us by the medical doctors. But this is a very clear demonstration that the thing actually works, and it's quite robust.
How does it compare with other heart monitors, right? Or not heart monitors? What's the breathing monitor that people use for?
Well,
yeah,
there's
is there an alternative?
Yeah, I mean, I think these things are measured with a sensor. You will see it in some of the pictures, and probably Lionel will be commenting. I mean, we haven't had the time so far to conduct a proper validation to be able to do a quantitative study of how what the divergence with respect to let's say a commercial sensor is.
Right.
So all we've done is to actually do some kind of visual validation, and the thing seems to be working. But of course, if this thing is going to be pushed further, this is something that we'll definitely be willing to do. Yeah,
it's 3 months, 3 months of effort. I mean, we cannot ask the whole world, right?
And
it's quite
believe
impressive,
me,
very impressive. Yeah.
All these things started from scratch. I mean, at the beginning, when the competition was launched, we had absolutely nothing. So it was only thanks to the different competences of the team that we could pull up all this work in such a limited amount of time.
Right. Amazing.
Okay, so this is about the breathing rate monitoring. Motor activity index. So here, basically, we wanted to devise some index that tells you roughly whether a child is moving a lot or too little. Okay. Or more specifically, we wanted to measure the motion of arms and legs. Okay, and then use this motion to define this activity index. This is again work to be done. So we are able to measure the motion, but in order to define this index, we need to talk with the experts and see how this thing can actually be done. So here, the first idea that we have was, okay, well, we have a thing called post estimation. So let's just use post estimation because this is going to be very simple. Well, that didn't work all that well. And probably it's not surprising that if you train a post estimation model on adults and you try to test it on babies, the thing is really not going to work.
Right.
Because babies, first of all, they have different body proportions, but also they have very different poses. So here we faced a design problem. This was already 1 month into the competition, and we said to ourselves, do we really want to train a post estimation model for babies, or can we come up with some other brighter idea that gives us some shortcut? Okay. Now, labeling all this data for post estimation would have been hell. I mean, we wouldn't have been able to get a post estimation model for babies in such a short amount of time. So here, actually, Danielle had this very bright idea, which was we're only going to use 2 bounding boxes. 1 bounding box around the face and 1 bounding box around the body. And using the relative motion of these 2 bounding boxes, it's more or less easy to infer whether you have the legs extended or an arm extended or the other arm extended. Okay. And again, this makes perfect sense. It's not the end of the story. It will need to be improved, but you will see it working, and it actually works quite well. So basically, it's just a relative motion of these 2 bounding boxes, and then some set of rules. You just compute how far are the edges of one box to the other, and you can define these quantities that are close to 1 if the leg or the arm is extended, and close to 0 if it's contracted. Okay. Again, very simple idea, but it does the job. Okay. And here there's also a video where you can see the thing working. See. Now here there's this small little puppet on the left is just hard-coded the set of rules. So here you can see more or less yellow means extended, green means contracted, and it seems to be interpreting the motion of the baby quite well.
Right.
Okay. Still a little bit noisy, but it does the job. And as I was telling you before, Satya, you see the range of motions that the baby does is relatively
Very
limited.
limited.
I mean,
Yeah,
this is what they do. They extend and they contract the legs, move a little bit the head, but this is pretty much it. I mean, in the first days of life, this is what they do.
Right.
Okay. So again, another example where a good design decision and a very simple idea got us to perform the task that we wanted to.
So here's the funny thing. I always say that you have to look at the data very carefully, and a lot of data whenever you try to solve any problem. Now, just looking at that one video, my whole question looks so stupid. Right? What were you even talking about? Look at the baby, right?
Yeah, well, I mean, yeah, you're right. I mean, I would have asked the same question, Satya,
Right.
because I mean, after all, as you say, I mean, until you get some contact with the problem and you get the specific knowledge, one has to ask all these questions as a scientist, right? And then you realize, talking to the people that actually really know about these things, that maybe things that you assumed for granted they need to be revisited, or the other things that you thought were very difficult actually are simpler. And this comes with a specific knowledge of talking with a medical doctor in this case, or having more contact with the problem.
Right.
But yeah, okay. So let me move over to the third algorithm. So this is called an emotional status detector. But again, this is just a fancy name for something which is a little more than just image classification. It's binary image classification. And here, this is the only model that actually we had to build entirely from scratch. So here we captured the data. We went over to the hospital. We recorded a few babies, different babies. And then we had these things labeled. And I don't know whether for the competition we mentioned that these things were labeled by experts, but now I can probably say that the experts were ourselves. Okay, so I think one more or less is able to understand if a child is having stress, or is crying, or he looks more or less calm. And here we're only counting on our own judgment. Again, if this thing is ever going to be pushed to a more professional thing, this probably would need to have some doctors actually labeling the thing, or people who have closer knowledge, but it works quite well. So what we did is we annotated the video. We developed our own software to label these videos on the fly. So just by pressing 2 keys while watching the video.
Right.
Okay. And then we use the built-in face detector. This crops the face. We train the image classifier. And then, of course, to avoid a very noisy signal, we needed to add some smoothing, so the thing wouldn't change all that quickly, because this thing is done frame per frame, and then we just added some smoothing to change only if there's a sufficient number of changes in the state. Okay, and validation of the results was done mostly again by common sense and inspection. So we played the videos with the emotion detector, and we realized that most of the times it was actually getting it right. Okay,
that's great.
So actually, I'll mention it in a second, but the score that we obtained for this for this model was an F1 score of around 0.8, which is reasonable for the limited time that we had. And again, probably with a much larger data set, this thing can be done even better. I mean, it's not a hard problem from the point of view of computer vision, but yeah, one needs to do it with care. Now, our dream, of course, would be to be able to extend this thing and detect other emotions, whether right. the baby is sleepy, whether he's hungry, whether he's got pain, and yeah,
that may be very difficult. I mean, sleepy, yes, that would be relatively straightforward, but hungry versus pain, I don't even know. I mean, can humans tell? It's very difficult, right? Humans can't tell why the baby is crying. It's a constant problem for parents, because they don't know why the baby is crying. You try, maybe try feeding them. If they don't stop, then you keep guessing, right? Maybe they have colic or something. So it's very difficult.
Yeah, you're right. I mean, this is not an easy problem. If you ask young parents, they will tell you that they do know, or that they learned by experience. Right. But again, all this idea is trying to encode this expert knowledge that the young daddies know by observing their children into something that can be actually encoded into some AI system. Right. So I would say it's not easy. but I don't think it's impossible either. I mean, you would need some very good and very careful knowledge of the babies. Okay.
That would be awesome if it is possible. Yeah, it's and especially if you have a lot of data, what was their last feeding time and things like that. If you have that information, then some of it would augment your knowledge of why the baby is crying. But it's funny. The other funny thing about babies, I just got reminded about this because of emotion recognition. We always talk about babies crying, especially when the baby is small, right? In the middle of the night, they would start crying, and it's the parents don't get sleep, etc. But the scariest time I had with my older son was, I put him to bed and I just fell asleep right next to him. And usually, you get woken up because they're crying. I got woken up because he was laughing. It was the scariest moment. I mean, just imagine a 1-year-old baby hysterically laughing in sleep. It was really scary.
Yeah, in my house when I was a kid, I know my parents would come in and check on us. I have 2 brothers. It'd be like, they're too quiet. They're up to something.
Right. Sorry, that was a diversion.
No, we all have stories to tell. Actually, when you were mentioning the difference between pain and hunger with my own children, I mean, for months the babies would be crying nonstop, and we were like getting crazy. What's going on? One day we decided to feed them a bottle, and that was it. And she was completely silent. So we realized that what was going on. So yeah, most of the times one doesn't really know what's going on.
Right.
But hey, whether this will be able to help one day or not, I don't know. But at least it's one question that one can think about. That's it's not science fiction.
Right.
Okay, so this is just a bit of a technical slide that I was mentioning already, but probably doesn't have all that much interest. The way we optimize happy parameters, we used a ResNet 50, of course, fine-tuning of it. And I think we did 15 epochs to reach an F1 of close to 0.8. Okay. And then, as we mentioned a while ago, we distill all this thing. We loaded into the OCD with OpenVINO, and it worked quite well, actually. Okay. And just to keep up what we were saying before, this thing with interpreting babies' emotions brings us back to this famous episode of The Simpsons, which I realized happened back in 1992. That's a long time ago, but maybe some people can remember this, the baby translator. So I'm going to play it for you guys. Let's see. Okay.
Say, nothing downstairs. You just took a nap. I want to suck your nose. Ooga booga, ooga booga, ooga. I'm scared. The amplitude of the sine wave is insufficient for burp me, and this sawtooth formation is something I've never. Eureka.
Okay, this is an all-time classic, and while preparing this slide, of course, I couldn't keep but thinking about this. So just a bit of a humor.
Like I said before, anytime we're able to work The Simpsons into the show, I'm happy. So thank you for that.
Okay, well, thank you. Now I think I'll pass over the floor to Angel, who will tell you a little bit more about the guts of the system and some more technical details. So Angel, if you may.
Thank you, David. Let me share the screen. Can you see it?
Not yet.
Go ahead and try again there.
Hold on.
We're also at about 35 minutes here, so let's try to keep her going so we can get to trivia.
It's working now?
Yep.
Yep, looks good.
Okay, let's go deep a little bit about the technological background of the project. Like in many other IT projects, there are two big different parts here: the hardware part and the software part. In the hardware part is the we call the NeoCam unit, is the device that is able to be located in the incubator to monitor the babies and applies or gather different data of the babies and applies of the different algorithms that David talked about. From the outside, this is the view of the NeoCam unit. There is a touch screen to see the different evolution of the different monitoring of the algorithms, the OD and 5G antenna for the connection. But in the inside, there are many different technologies or hardware part that have been open source or commercial solution, like a Raspberry Pi, the latest model of Raspberry Pi 4, a hard drive that we actually has never used, because the first time we thought about to record the videos and store in the hard drive, but finally we implement a streaming based solution. So this version is still located in the NeoCam unit, but for the future version probably will be removed. A 5G connectivity shield. The current version is supports a hybrid access network supported by Wi-Fi, provided by the Raspberry Pi, and also a 5G supported by a connectivity shield. In this case, the system send all the information through Wi-Fi. It is possible. It's not. It's connected to the cellular data to send the different information. The display to see the information, the SD card to store the Raspberry Pi operating system, and that's all.
Wow.
Of course, the OG camera, and finally the 3D printing box that we design and print just for this project. Actually, this is a very big device, because it's really easy to handle it, but it's a very big device. We were thinking about with the new OD lead and using Raspberry Pi Zero, we reduce significantly the size of the NeoCam units. It's a really good improvement for a future work.
What's the cost of this unit if you add up all the components? Roughly?
I
Less
guess
than
it's about, no, it's about 200 euros. Yeah, it's about $250, I guess.
Wow.
Well, without counting the OD camera. Yeah. Because the OD camera is about also $230, I think, $200, I think.
Right. And
But,
OD Lite is, it's even the retail price would be $129 or so. So it's pretty, it's under $500, which is very, very attractive.
Yes, it is. Okay. And the other part is the software or the different services implemented to provide the different functionality that we like to support with the NeoCam. There is a big picture, an overview of the entire system. Our system is basically based in a cloud supported solution, in this case using Microsoft Azure, which was the sponsor of in the OpenCV contest. On one hand, we are using the different services that provided by Microsoft Azure, like media services for the streaming, the storage, the IoT hub for the real-time communication through MQTT protocol, or MySQL server to store the information of the baby. So in the left side of the picture, we have the NeoCam unit, which is sent the information through Wi-Fi or 5G to the media servers for the streaming, and at the same time it's sending the information through the RESTful API implemented in JSON notation. Okay, there are many different technologies involved. We develop all the backend in Python. Okay, at the same time, the NeoCam unit is sending information, and the Microsoft Azure backend is storing and processing the information. The doctors or healthcare professionals, as well as the relatives, are able to get all of this information at real time. This way, the NeoCam unit is sending information to the backend. The backend is storing, and in some cases broadcasting the information. In this case, the streaming for the mobile application. I will talk a little bit about the mobile application in a minute, and also is processing and sending the information to the parents or medical staff using MQTT protocol, also using JSON notation. This is a summary about the technologies that we have used, in case any of the audience are asking about the what technologies have been used for the development of the implementation of this project. Python for the backend, using Flask for the design and development of the API, SQ Alchemy for the store of the information at the first version of the development, Java Android SDK for the mobile application, MQTT protocol, in this case a specific implementation provided by the IoT Hub by Azure MQTT. For the streaming, we use the OpenCV to process the image from the camera and send it to RNTP server. The first version was implemented using a RSTP server, not RNTMP server. It doesn't work really well, so we decide to use our RNTMP server. Okay.
Could you just tell the difference between the two for the general audience?
Well, supposedly the RTSP server is supported by Adobe, the same company of the Photoshop. Actually, the decision that we didn't finally use the RTP server is because I don't know why, but it's not working really good with Android platform. We also use the native libraries provided by Google, but it doesn't work really well. So we decided to move to another proposal like RTMP, which finally very good, as you can see in a few minutes in the mobile application. Works really good, really fine, quick, really fast. So we were happy about the result, the outcome of the part of the stream, because it's really helpful for the relative or medical staff to see at real time the baby what he's doing, because you can see a chart or you can see a graphic. It's very illustrative if you are able to understand it, but if not, it's much more efficient for parents to see his baby or her baby at the real time. And the big part is all the different services and technologies provided by the Microsoft Azure, like the Azure App Service for the development and deploy of the REST API, the media service for the streaming, or the IoT Hub for the real-time notification. Well, this is the mobile application. In order to, there are many different technologies. The three algorithms that David talked about, it generate many different information, but the way to display or disseminate this information properly, we decide to construct a mobile application due to everyone has a smartphone device. So it's really easy to take out your smartphone from your pocket, open your application, and check at real time the different information that we like to check. Okay, the application supports a full-time telemonitoring system for the babies. Also provide aggregated statistic about the different parameters that are monitoring the babies. It's really, or we try to design and develop a friendly and easy to use application, because supposedly will be used by, like in this case, for example, for relatives, that people that are not to be expert in the area of medical field. I have here a video. It's a quite long video because it's 7 minutes long, but I will try to go jumping to the different part or the main part of the application. Okay, the application, like many other applications, has a login screen. There are two different profiles here supported, one for the medical staff and the other one for the relatives. Depending on the type of user, you will see one type of view or the other one. In this case, we will log in with the healthcare professional, the doctor. Okay, let's go further. Once the credentials are correct, the first view that the doctor is like it's a kind of wall, like in Facebook, like you can see the most important highlights of the different baby that you are in charge of. Okay, so for example, if the one baby has kind of stress, the number of anomalies, if it has any kind of problem about the respiration, whatever, when you click on one of the babies, you are able to check on real time the different values, processes after using the algorithms that David talked about, the activity, respiration, or the stress. You can see the value, also the last value, in case you want to check is this going up or going down. Okay, in case you click in one of them, you can go a full chart about the data in order you want to go the evolution of the time. Okay, I guess here the time frame is about 5 seconds or 3 seconds, so that's why the chart. Yes, there is a log to see the information specific. In this case, is for the last hour, but you have another option like 6 hours, 12 hours, the last day, last week, last month, or customs date, defining the start date and the end date. They are the same view for the 3 different monitoring parameters. Okay, it's exactly the same. This only one. This is the custom selection of the date. Okay, let me go. You can check.
Amazing how we can now build these applications relatively quickly because of all the components are usually available, right, for building these things quickly. Like you mentioned, all the backend for using Microsoft Azure, you used even in the front end, the graphic libraries, everything is available now. 20 years back, it would be a much different story, but you can put these things together relatively quickly, very fast, if you know what the right stuff to use.
Actually, the use of third-party libraries or third-party services are really useful because you can reduce your development effort in 90%. You just use what other people have done. So it's really, really useful to develop this kind of stuff and very, very quickly, as you said. Okay, let's go move. This is the third parameter. It's exactly the same. Okay. This is the third tab is a kind of summary of a specific baby, showing the stress, the respiration, and the activity for today, for yesterday, 2 days ago. And finally, this is the streaming, where you can see the baby at the real time.
Wow.
Okay.
Yeah.
This is the view. It's crying now. This is the view of the medical, the haircut professional, and okay, sorry, I forgot, because the application support real-time notification. So if something is wrong, the doctor or the relatives are able to get a real-time notification, like in WhatsApp or any other kind of application. A pop-up message that you can click to see the monitoring or see the streaming at the real time. In this case, we click in the monitoring, so just move to the monitoring view, okay? And exactly the same for the streaming.
Right.
And the second view is for the parent, which is more simple, because it's just the name, our overall evaluation, and the streaming is all the information that is provided so far for the relative, but it's enough for the parents to check if his baby is fine or not. At the same time, also is supported the real-time notification for the parents. Your baby is a little bit stressed, you can click and you can check at real time what's going on. Okay.
Wow. It's really
Extremely
very
cool.
useful.
Yeah.
Actually,
how many slides y'all got left here?
Let me check.
Can you do a quick time check? Yeah.
Let me check. Oh, now is the turn of Lionel. I guess he will finish in 5 minutes.
Let's pause here on the presentation. Go ahead and unshare your screen, if you will, Angel.
Yes.
So we'll do a quick the question, the competition. We do the quick question, and then we'll come
Yeah.
back to the presentation.
Sure.
Yeah, so if this is your first time joining us, we do a giveaway with every episode. It'll be based on a trivia question, which I create based on the slides for our guest this week. Satya, would you like to remind them all what they'll win if they answer the trivia question correctly?
They will win 200 hours of free Azure credits. You can use it for training a machine learning model, do whatever you want.
Yes, and then like our esteemed guests here, it can be used in situations even like medical stuff like this. Pretty cool. Thanks again to our generous sponsors at Microsoft. We really appreciate it. So the way this works is I will ask a question based on the slides. You will answer that question in the Zoom chat window. If you have won a trivia contest here, please don't answer. Let someone else get a chance to win.
In the last 5 weeks. Let's put a limit. If you have won it before the last 5 weeks, yeah, sure. Go ahead, answer.
I think that's fair. Yeah. So if you've won in the last 5 weeks, please don't answer. But if you won before, it's okay. Only one person can win, so be quick. This one is a pretty easy one, but I again want to. You'll see why. So Team Coletta used a specific tool to shrink their models down by up to 50%. What is the name of that tool? All right, we got it here. I think I'm looking at my screen. I see Bikram says OpenVino, and that is correct.
Yeah.
So congratulations. Please send me an email to phil@opencv.org, and we'll make sure that you get your Azure credits.
Thanks.
And
okay,
let's continue on with the presentation.
Continue.
Who's next? All right, there you go. Lionel, you're muted, by the way.
Sorry.
All right, there you go. You're back now. Okay, and we can see the slides.
Okay. How many minutes are left? I mean,
oh, you got time.
Don't
worry about it.
Yeah. Even if you go over a little bit, it's not a big deal because people can see the recording.
mm-hmm.
Yeah, we just wanted to get that question before people had to leave. Yeah.
Okay. This last part is just to show some of the results we got, how we develop and tested these things in real NICU. So here in this picture, we show the first test that were done with this articulated arm attached to a vertical bar where we had the OGD here and connected to a laptop. We use it for twofold things. I mean, firstly, for testing the first versions of the algorithms, and also for recording videos with the 3 cameras of the OGD. I mean, one of the wonderful things of the OGD is that you pre-process most of the data in the camera. So as was described before, you just need a small computer like, small, relatively small, but cheap and small computer like the Raspberry Pi 4 for doing the rest of the analysis. So we recorded many hours of video in an actual unit, the NICU unit that is at the Hospital Puerta del Mar in Cádiz in the south of Spain. Here in the left side is woman is one of the medical doctors. She's a pediatrician expert with expertise in neonatology, one of the inspirators of this project. So we recorded many hours of videos of the order of, 25 hours over 9 children, different children. Different children are different stages of growth. This is very important because at that ages, their weight and their size varies very quickly. I mean, in 1 week, they can grow like 30% in weight, for example. And also depending on the age of gestation, I mean, if you are born 2 months before proper maturation, like Phil Nelson mentioned before, that you are about 1.5 kilos.
Yes, I was almost two full months premature. I think it was like 7 weeks or something. Yeah.
Yeah. So the size of your body, the kind of movements, the dynamics of your sleep-wake cycles, your respiration rate is completely different for a baby that is born 2 weeks later. Also, even being a preterm, there is a lot of variation between different cases. So we have to record videos from many different babies at different stages to see if our algorithms were robust enough. One of the things that mentioned David, and I mean, well, the main inspiration or goal of this project was to measure things that cannot be measured nowadays, particularly the movement of the limbs, the general movements of the babies, and the emotions, because these are they're linked to neurodevelopment of the babies. I mean, preterm babies have much higher risk of having problems in neurodevelopment. I mean, the brain, for example, can have infections, hemorrhages that affect the maturation of the brain, that can have a long-term impact for the rest of their life. In fact, many proportion of these preterm babies, especially those that have been born many weeks in advance, have a higher risk of having, for example, cerebral palsy, problems with motor or with movements when they will be childs, or even lower in capacity, cognitive development, so they don't have the full ability that will have a normal child. So the inspiration or the main goal of this project was to be able to diagnose or trying to be able to diagnose somehow if a child is having this type of an abnormal development because the brain is not developing properly. So there is a lot of research in medicine about ways of getting these biomarkers from babies for this type of problems. And one of the most common are those of measuring the patterns that of the movements of the babies, the legs, how they move the legs, how they move the brain, the arms, how they move the hands, and how these movements are correlated. Also, the frequency of emotions, the type of emotions, all this is a very important indicator of that something is happening with the baby. So the sooner you can get that information, the sooner you can try to react for the doctors to apply some kind of treatment or care on these babies. So that means that we have to test this algorithm with the baby that we didn't have enough time. I mean, in 3 months we didn't have time to validate this tool, but I think that we hopefully have reached the goal of demonstrating that it's possible to do this type of measurements that normally are done by experts. I mean, doctors that have to sit in front of the incubator for 5 minutes, I think is the standard, and they have to watch the baby, how they move for 5 minutes, how they react, and only after that time they can try to give they apply some tables, and they say this baby is not moving properly. But what happens? These doctors are scarce. I mean, there are not many doctors that are trained for this. This is something quite new. And also, I mean, doctors usually, you have in an ICU maybe 10, 15 babies. Doctors cannot be doing this kind of checks to every baby every 3 times a day. So if you can have a machine that do this type of assessment, that they can do it 24/7, well, I think that could be a good, very good game changer, I think. So then, as I mentioned, we have to test also the camera. One thing is the algorithms, but then you have to see what are the conditions in which you are going to image the babies. If the baby is facing up, facing down, as you can see in this image, some of the babies are facing down. Even if they are facing down, you can see, we were able to see to check the breathing from the back, because the back also moves. what we really found difficult that is for very early preterms, the respiration rate is not is not a problem of frequency. It's about how much they move. So it was maybe in some cases difficult to measure these changes. We have to check if with the camera we could see through the incubator itself that is made of PVC. We have to check what was the right position for to locate the camera, because the camera, depending on where you put it, can interfere with the normal care that nurses and doctors do. So we have to consider that properly. That with care, that we needed a camera that was compact enough and that didn't disturb the normal care that is carried out on these babies in an NICU. That's one reason why we use wireless connection, because we wanted to reduce the number of cables to a minimum. At the end, we had only one cable for the power supply. But of course, wireless has a problem in general if you want to implement that in a medical setting, especially in a hospital, is that there is a very restrictive place in terms of information transfer. You cannot transfer information easily from a hospital to the outside world. In fact, it is very, very, how do you say, restricted. Huh? But we were thinking on the doctors, that the doctors can have a mobile, they can be having a coffee or be in another office, and to have the data of the babies continuously received in their mobile phones, or for example, parents that are in another room without disturbing other parents that are taking care of the babies, to be in another room and to check, for example, with the video in real time, they can see the baby from another place of the hospital.
Right.
Then we did some tests, for example, here with the breath rate that you saw the video before. Here you mentioned if we have compared that with the real monitor that is actually measured. This image in the right, in the bottom right corner is the actual monitor that was checking this baby. You can see three curves, and the one in the lower curve in blue, in light blue, is the respiration rate of the baby. You see that there are some oscillations, and suddenly it stops, is flat, and then oscillations again, and it's flat, and then irregular. So this is typical of preterm neonates, where they can stop breathing for maybe 10 seconds, 15 seconds, depending on their maturation.
Wow.
And also the respiratory rate can be very irregular. It's not like, I mean, an adult or a more mature baby would breathe more regularly, with a more fixed frequency. Anyway, so we were able to follow the trend. We compare, not quantitatively, but yes, we were recording at the same time, as you can see in C here, the top right picture. You can see that we were recording at the same time the screen of the laptop, and at the back was the monitor.
Yeah.
So we just show here the inset show a magnification of the monitor with these three peaks, that were these three peaks. So we were carrying this kind of tests for several kids, different stages, and we saw that we could follow the respiration rate. But of course, again, this needs much more validation. Just to finish, this is the actual camera working. You see that the size of the camera, the location with an articulated arm, the only cable that is the one for the power supply, and was robust enough to be able to put it from different perspectives. I mean, from the right to the top, from the top of the incubator, or just through the window here that is a 45-degree incline. And it could work in different cases. That is good, because not all the incubators have the same entourage or environment. So it's difficult. It's a crowded environment. Yeah. So having this kind of flexibility is good. This is an actual capture of the screen, touch screen on the NeoCam unit in action, where you can see the blue square that controls or monitors the movement of the limbs. The yellow square is the breath, where in the region where the breath is measured, and the green box is the face detection, and also is labeled with the non-stress in this case. And at the right side, you can see the curves obtained after measuring for a period of time. Just to finalize, I want to say that this work was this competition arrived at the right time. We are involved in a European project called Parent. Here is the web that is especially devoted for the application of new technologies for trying to diagnose earlier and better the problems of neurodevelopment in preterms. So at the right time, we saw the competition and we got inspired. We thought about the things that we could do. And then, well, INIBICA is also an institute of research in biotechnology of Cádiz. The doctors, the two doctors that helped us in this project work is the place where they work. And just to finalize, this is a project that was done in 3 months. I mean, maybe the algorithms are not the most complex in the world, but they function, they work. But is also hardware, is also IoT, is cloud computing, is 3D printing, and we had to do all this in 3 months. And this was possible because we managed to organize a team of people with well-defined tasks. Here at the left side, we can see the picture of Isabel Benavente and Simon Lopez, the two neonatologists that are well-known researchers in this field. And then we have Daniel Precioso at the top, Javier Jimenez, Leopoldo Gutierrez, and Andrés Millán that were deeply involved in all the hard coding of the project. Blas Salvador was involved in the hardware development, especially in the 3D printing, 3D design of the enclosure of the camera. Angel Ruiz that was involved in all the cloud computing and web development. David Gomez Ullate and me, that we were helping also with the algorithm, machine learning, different concepts, and trying to organize a bit everything, also with the tests in the hospital.
That's great. And I think when they write the history of contactless, monitoring of neonatal babies for better support, I think your team, all the people here will be well recognized for, you're one of the first people to do something like this. So it's really heartwarming to see, your team coming together and doing this thing. It's amazing.
I mean, I think it's not completely new. I mean, some of the monitorization and the algorithms that we use and the whole unit is new, but this is especially new because it was possible nowadays to do this. I mean, amazingly, the OACD, as was mentioned before, is a machine that in a very compact format can run 3 models models at the same time, plus the 3D estimation.
Right.
I mean, it's very impressive that you can do that. I mean, we have worked with the edge computing hardware for computer vision for several years now, starting from the Jetson TX2, the USB, the memory stick from Movidius, the OpenMV, that is a fantastic also machine. But it's true that the OACD, not just because we won, but it's amazing that you could do all this also with a very good documentation, with many examples that we could get up and running and in 3 months to do all this.
Thanks. So, I mean, obviously all the credit goes to our hardware partner, Luxonis. They are the ones who push these things very hard. And, that Luxonis team is always very responsive. If you buy an OACD, join our Discord channel, they are very responsive and support, etc. also. And so one other thing I wanted to mention is that the neural compute stick, NCS, and OACD, they have the same Myriad X chip inside it. The reason Myriad, OACD is so fast compared to a neural compute stick is because the camera is directly connected to the processor, right? You don't need the host to connect the two. And that's why you easily get 3 to 4x speed up just because of that.
I imagine that that was not easy.
Yeah, it's
yes, of course.
a good piece of hardware.
Yeah, they
all right.
perform
we
some
have-
serious feats of engineering over there for sure.
Mhm. If we have time, we can just put the video. We
That would
want
be
to
great.
show the video that we can summarize everything.
Yeah, so the final
today.
submission video, this is the final submission video which won the competition.
Yes.
Yeah.
Yeah. Can you turn on the volume?
We might not have audio. You might need to reshare your screen, and remember that little checkbox in the corner? It happens.
For the sound, no? Sorry.
Yeah,
was
it's
start again.
okay. Zoom does not necessarily make it easy.
While we are waiting, I just want to announce quickly that we do have the next competition already live. Phil had shared the link and he'll share it again so that, please check out that competition if you're interested in the next competition. It requires you to build a manufacturing solution using Lego pieces and OpenCV AI kit.
Yep, I just dropped the link in the chat there. Let's watch the video.
Caleta team at the University of Cadiz has developed NeoCam. NeoCam is a monitoring system that allows 24/7 surveillance of newborns and babies that use the O camera and incorporates new computer vision models and hardware improvements.
The core element of the NeoCam is an OAK camera, where we have included some new machine learning algorithms for computation on the edge of relevant features of newborns' activity and status. Physiological data are usually measured on newborns by attaching physical sensors and cables. Our system allows many of these quantities to be measured without any contact, by using purely a camera and computer vision algorithms. We believe this will have an impact in the future of newborn and baby monitoring.
The system involves placing the NeoCam device on each incubator and collecting the data and signal real-time on the cloud. The server stores all the relevant information and serves the processed information to medical doctor or parent through a mobile application, installed on a smartphone or tablet.
The internal elements of the NeoCam are the OAK camera, a Raspberry Pi, which does part of the processing, a hard disk, and 5G connectivity shield.
We have built a prototype which includes all these elements, and we have tested in the wild on the newborn unit at Hospital Puerta del Mar in Cádiz.
The first model of the NeoCam is capable of registering 3 important quantities for newborn monitoring: breathing frequency, motor activity, and emotional status. All of the models process the images captured by the camera, and they are run inside the OAK camera.
Breathing frequency is measured using the depth object estimation provided by the 3 cameras inside an OAK. A standard face recognition model detects the face and relative to it, places a reference region on the chest. Contraction and expansion of the thorax while breathing is measured in real time and results in an accurate estimation of breathing frequency.
2 standard object detection models capture bounding boxes on the head and the body of the baby. The relative motion and relative sizes of these 2 bounding boxes allows us to detect whether the left arm, right arm, or legs are extended or contracted. Computing the frequency of these motions allows us to provide an activity index of how active the baby is over a certain period of time. In particular, we can also measure sleep-wake cycles with this technique and monitor the newborn's psychomotor development.
We have recorded a number of videos from newborn babies and set up an annotation platform for experts to label their emotion based on their face expression. Then we train a new image classifier that is able to recognize with reasonable good accuracy whether the baby is stressed or calm. The model has been loaded into the OAK using OpenBino, and it performs inference on real time inside the camera. Recording and measuring these stress or pain periods over a large period of time is a very good way to detect the deviation from the baby's normal development and raise alerts to signal potential problems.
The NeoCam with the OACD is just the beginning.
Yeah, the video was also amazing. The whole presentation was, you know, the submission, the work you did, but also the final presentation video in the competition was amazing. And people don't realize that it's very important to not just do excellent work, but also present your work so that people recognize that it is excellent, right? The presentation was very nice.
Yes, I agree. Congratulations again on winning second place, and yeah, it's a very professional presentation. That again, some places might take 3 months just to make the video, and you did all of this, including building the hardware in 3 months. So really impressive.
It was done by a pro. I mean, the video.
As a video pro, I appreciate it.
Nice.
So yeah, I mean, do we want to do a question? What's our? I'm looking at time here. We got it's about 1:20 here in Michigan time.
Let's get a few questions, audience questions.
We'll do a. So Dan would like to know how much of this, how much of your work here has been open sourced? Is any of it available publicly? That's for anybody.
Well, it's a good question. At the moment, was open for the evaluation during the competition, so the jury could test that was really what we were saying that we could do. But at this point, we are trying to push this forward. So I think we have described everything. We are going to publish also in a journal the project, but obviously we are considering pushing this project forward. Maybe we cannot open all the code that we develop, but we will make a thorough description of the full project in a journal.
Okay.
We're basically figuring out where to take things from here. I mean, we're just
so you're considering productizing this, and you don't necessarily want to give away all of the secrets. Is that more or less what you're saying?
Yeah, I mean, there are not all that many secrets. I mean, if you followed what we explained today, anybody with a little bit of time could reproduce everything, because there's nothing of this is rocket science, right? But it's a lot of work, and we are now considering whether we want to take it to the next level, or I don't know. It's a discussion. It's an ongoing discussion within the team, and we'll let you guys know whenever we reach a final.
One has to have some balance, right? Because once you submit to a journal, it's already. I mean, even as part of this competition, you have pretty much told the details of what you're doing, right? And as you said, that it can be replicated. And if you guys are planning to make a product, then maybe open sourcing is not, people should completely understand, right? That, if you want to build a product around it, maybe you will not open source it. But the knowledge has been distributed as far as I'm concerned. You have clearly laid down the path of how to build this thing, right? The components are there, even the machine learning models you have mentioned, right? So it would be great if you in the future open source it, but even what you have produced until now, it's a great service to the community, in my opinion. I
mean, there are many ways of giving something to the public. I mean, the whole idea, the concept of integrating all these, the technologies, the app, everything. I mean, is a source of information. Even the models and the algorithms will be described. But I mean, we haven't taken a decision because on the other hand, we think that, okay, it's open source, we provide the code, but it's something that needs still a lot of development and validation. It's true that opening code to community, maybe it would be also a way of making this really a robust and properly developed thing. But maybe not. We are not at that stage yet. Probably it would be is something that we're considering also.
Right.
Yeah, that makes a ton of sense, and also I think you all have the right attitude that the real value here is the labor, the work putting in and making the things work together, and I think that's you're in the right headspace for that for sure. We got another question here. Bob would like to know, have you considered using this tech to detect sleep apnea in adults?
David, do you want to mention this?
I don't think we've thought about this application in particular. We did toy around the idea of see whether this could be used to predict this sudden death syndrome in babies, which
SIDS you're talking about.
Yeah, which is a big concern, and sometimes it happens through just I mean, nobody knows why, but the children stop breathing in the middle of the night. So if they're in the cradle and they stop breathing, I mean, if you get a very big alarm on your bedroom and you're able to do something, I mean, this goes really beyond my understanding. But this is one of the applications that we thought might have a largest impact, also in domestic use of these tools.
Right.
And of course, we don't want to limit ourselves just to intensive care units, but eventually the market is much higher on the applications if you actually move over to the domestic setting.
Yeah, that makes a lot of sense. I think there's so much that can be done here, especially with the tight integration of the hardware and software and the affordability. Again, we're looking at less than $500 here, so it's really something. We lost your video there, Satya.
Oh, I'm here.
Restart that fancy camera of yours. Okay, we'll do another question here. Joe asks, what is your expected typical backend cost for Azure, the cloud processing and whatnot per device? Obviously, it matters how much you're using it because that's how they meter these systems. But what do you expect? Like, what kind of usage have you seen in your installation?
I think we lost
actually,
Uncle.
Yeah, well, actually, we did use
Oh.
the promotional code provided by the Microsoft. In this case, was I guess $400. We spent 2 months to use all the different money. So I guess about the cost of the project, I guess probably about $50-60 per month, about 8 or 10 babies, I guess.
Yeah, that's really affordable. I'm surprised by how low that is.
Yeah, the thing is that you don't send the whole set of images. They are only stored inside the hard disk and the Raspberry unit, and you only send the images when there is an anomaly. So you only send a small excerpt of say 1 minute or so. So at the end, the usage you make of cloud computing is rather moderate. So the costs
really
are almost negligible.
Yeah, it really shows the power of edge computing there, that you're able to do it all locally. So you can get that, it's cheaper, but also much more efficient data wise.
I'm actually very surprised by the price myself. I would have guessed a few thousand actually, but that's great. Yeah.
I guess we're butting up against 90 minutes here. So you want to take us home, Satya?
I have one announcement before we close the session. OpenCV has also made the Python course for free for a few days. We are testing whether we can support a lot of users for free. So the Python course is free if you are a C++ developer, you don't have experience with Python, you have never used Jupyter notebooks, never used NumPy and things like that. It will be it's a great opportunity. And once you get enrolled, it stays with you. You don't have to pay anything. It's a free. So it's free for about 11 days now until the next week. So please enroll if you are willing, and we have not made it free, completely free forever, because we don't know how we will be able to support, we want to make sure that we are able to support our paid courses, and the same support staff is also going to support this free course. We are testing it out. So that's one announcement I wanted to make. And of course, the competition that I mentioned, the next competition, please go and participate in the competition. As you know that we have a big reach. If you, as part of that competition, by the way, if you win, you will get a chance to showcase your solution at Microsoft Build. It's a very big deal, right? The prize money is not as much as the previous competition, but look at the exposure you get. So you will, if the Microsoft Build is a physical, in-person next year, which we are hoping it would be, in that case, you will get all the expenses paid, and you will, one member of your team would be able to go and present it at Microsoft Build. That's a huge, huge deal. So yeah, so please check out the competition, and if you have ideas, please participate in that. With that, I just want to thank Team Kaleta for this great presentation, for making the time, and also for submitting this awesome submission in our previous competition. Thank you so much. Thanks for showing up here. And Phil, thank you for organizing this. And finally, thanks our audience, who we have been going over a little bit, but I hope that this has been very inspirational and it's worth your time. Thank you so much.
Yes, next week, our guest will be Joseph Nelson from RoboFlow, and the week after that, we will have the third prize winners, Team Cerebros. So join us again every Thursday, same bat time, same bat channel, 9 a.m. Pacific. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Microsoft Azure and Intel, sponsors of the world's largest spatial AI competition, OpenCV AI Competition 2021. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.